Thanks, Mark. And what I wanted to do is translate. This is the work we did around SMT optimizations is a very specific example of performance. I just wanted to also point out that, again, to my sort of theme with the energy collaboration, performance is something which really permeated Windows 7 as an engineering organization and how we approach the system and how we use telemetry to gauge ourselves on performance. And Mike mentioned that this is the first release of Windows where we're not doubling system requirements. And really what performance was about in Windows 7 was, first of all, creating a system which we could better measure and better create that telemetry on what's actually happening in real end-user systems. And it was about responsiveness, because what we've learned over time is that to focus on the responsiveness of the system and the task user's doing is more important than focusing on a benchmark of raw performance. What the end user really wants is a system which, in the tasks they do, delivers the performance. And so that's what we did spend a lot of time measuring. So performance really permeated graphics, where we did, for example, Intel was our first partner to deliver WDDM 1.1 drivers to us very early, which allowed us to save, in some cases, hundreds of megabytes of system memory that adds performance to the rest of the system. Intel also, in areas like storage, we've seen some examples of SSD, and I'm about to show you one where Intel's SSD team did a lot of work with us to really optimize the algorithms in the solid-state drive to make sure that it's optimized for the workloads that real users see. And also another good example we were talking about earlier was networking, where we spent time looking at those scenarios around on-off transitions, and hey, wouldn't it be great if you can resume from standby on an Intel system in a second, or sub 1 second, and then get the Wi-Fi connected and actually be downloading email and Outlook. And that sort of scenario-based approach is what you'll see, those of you who are using Windows 7 or will use Windows 7, is the focus on scenarios and optimizing the whole system. So what I wanted to show is a really good example of optimizing the whole system. So what I'm going to show you is a boot demo, and this is an Intel reference design, which is provided to Microsoft. And we found out just by when we were doing some work that, wow, you take a really powerful Core i7 processor from Intel, and you take a really powerful I/O system. Well, those are two of the very important ingredients in booting a system very quickly, and booting the system is one of the core on-off scenarios. And the third component of booting a system is initializing all of the devices and getting all of the work done in the operating system that needs to be done to initialize the system. And that's where the Windows 7 team had spent a lot of time with new technologies new technologies in Windows 7, such as trigger start services. So we took over 50 of the services that ship in Windows 7 and made them such that they don't start during boot, they start when an event occurs. So my favorite example is Bluetooth. Why spend time initializing Bluetooth during boot if there's no Bluetooth device present? Instead, let's do that initialization and start that service when a Bluetooth device is configured. And we spent a lot of time optimizing components. There are over 500 plus component optimizations in Windows 7 of the key OS components that aid in this sort of making the OS leaner for the end user. So let's do the stopwatch test. Everyone whip out their handy dandy Timex, and I'm going to count down. Hit enter. I'm going to go 3, 2, 1, and we now have a high data rate from the Intel SSD. We're actually making use of the enhancements we did for hyper-threading, in that we removed a number of, we're at the desktop, so we're done. We removed a number of the thread locks that we found during the boot process. So we found instances where literally this Core i7 was sitting idle waiting for a system lock in the operating system. By removing those, we now can use all 8 cores in this 4-core system to be initializing devices and building up a file system and doing all of the necessary work to boot the system. And the result, through many timings, you should have seen we're just below 11 seconds in terms of how long it took to boot this system. So again, Windows 7 installed on an Intel reference design with some very high performance hardware. This shows, what system manufacturers can do by picking the right components and on Intel platforms is building systems that have great end user scenarios.